Okay, so here we're going to take a look at the area of a triangle. Right now, first let's take a look at a few differently shaped triangles. And let's say we had something like this, then like this, and something like this. Okay, so this side right here is what we're going to call the base, right? If we think of it here, here, and here. All right, so one of the sides we'll call the base, and then the highest point from the base, right, kind of where the two other sides meet, we'll drop a diagonal, a perpendicular, sorry, not a diagonal, a perpendicular down to the base. And we'll call this distance the height, right? Now again, the perpendicular does not need to be on the base. It could be on the line, like a straight line kind of extending from the base here. All right, so we can have it like this, right? And then this would be the height. And then for something like this, right, we have a right triangle. Then one of the legs, we would consider the height if the base contains that right angle. Okay, so we want to derive a formula here. Now, it doesn't really matter which one of these three types of shapes we have, or if we can generate any other type of shape here. They're all going to have the same formula for the area. All right, now if we just take a look at kind of this first one here, and then we'll see kind of our approach to finding the area formula here, right? So if this is our triangle here with some height h, right, and some base b, right? So what I want to do is I want to, all right, draw a line that is parallel to this side b. So it would be here, and it would be the same length, but parallel to b, the base, right? And also another line here, right? So they kind of intersect here. So it would be parallel to this other side of the triangle, and also the same size. All right, so congruent here. So, okay. So what we can think of the shape that we have here, and maybe let me fill in that dashed line here. All right, now in creating something like this, we have essentially a parallelogram, right? Recall what is the conditions for a parallelogram. Opposite sides are parallel. Okay, and then the opposite sides are congruent. Okay, that was one of the properties as well. All right, so essentially these two triangles that we have here, so this parallelogram is composed of two congruent triangles. Right, they're congruent because of the way that I constructed them. Okay, all right, so what happens here, I know the area of the parallelogram, right? The area of the parallelogram is base times height, but I'm not taking into consideration the parallelogram. I'm taking into consideration the triangle, which is half of a parallelogram. So, in fact, the area for any triangle, right, and we can do it with any one of these, will follow the same logic, will lead us to the same formula, right? So the area of any triangle would be 1/2 base times height, right? So area formula for any triangle. Okay.